to my talk, Mission to Mars, Exploring New Worlds with AWS IoT. Today we're sending a robot to Mars, and we're using Amazon's IoT framework to do that. Let me start with a few warnings. I won't be showing any Java code, so if you're just disappointed about that, maybe you can still go somewhere else. And the other one is, I woke up 3 o'clock this morning to be here. And so if I fall asleep here, then just yell and I'll continue. First thing about me, I'm Jeroen Resoort. I'm a Java consultant working for JDriven. JDriven is a small company in the Netherlands doing consultancy for the larger companies in the Netherlands, mainly doing Java and other JVM language development, and also some front end. And we're all geeks trying to learn new stuff and having fun doing so, and also sharing it with others. About this talk, like I said, we're building a robot that's split into two parts, basically the hardware and the software part. After that, we'll look into Amazon's platform, and we'll finish with a demo if everything still works. Okay, so inspiration for this. Well, first of all, clouds. We're connecting our robot to the cloud. Well, mainly I like robots. I think it's because all my childhood heroes were robots. Well, not all of them. And I like science fiction. So a robot into Mars, that sounds like cool science fiction. Well, actually, it isn't science fiction. Already 20 years ago, the first Pathfinder mission landed, and the rover explored the surface. It was successful, and several other missions followed, were also more or less successful. But, well, it has already happened, so it's no science fiction anymore. So if they can do it, we can do it. So if we build our own robot, what do we want to do when we drive around on Mars? Any suggestions? Yes, I don't see any hands, so just say something if you have an idea. Oh, well, I would say I want to move around with the robot. I want to take pictures and gather other interesting data. So if you want a robot to do that, what does it need? Well, first of all, power. It needs a power supply. It needs connectivity. In our case, we're cheating a bit. We're just on Earth. We have Wi-Fi. And it needs a camera and other sensors. So, where to start? If you go on the internet and look for robots, there are so many robot kits available. Which one should you pick? I stumbled upon one project, a Kickstarter project called Mbot. It was a very successful project, was funded within 24 hours. And the slogan was one robot per kit. So it's basically not too expensive robot kit for children. So this was the Mbot, and it's easy to build. My own children built it in 10-15 minutes with the manual. And it's based on Arduino, and it comes with all kinds of sensors and connectivity included. So it's quite a nice set to get started with. You don't need to buy a lot of additional things. And you can power it with either batteries or AA batteries or a lithium battery. But the coolest feature I found with Mbot is that you can program it with Scratch. Who is familiar with Scratch? Well, 50% maybe, a lot of hands. So the people that don't know Scratch, it's a graphical programming environment where you can just drag and drop your instructions into these colorful blocks of instructions, and it's understandable. It's easy to learn, and it's great to do that with kids as well. This is an enhanced, an adapted version specific for the Mbot, where you have specific components that you use for controlling the Mbot. And also, if you put on the advanced mode, you can see on the right hand side the Arduino code that that would be that will be executed on the device. So that's not in the normal Scratch, but it is in the Mbot Scratch. But you can hide it. By default, it's hidden, and you can just play with the blocks. I did a workshop last year with 15 kids playing around with the Mbot, and it was great fun. It's cool to see how quickly they learn things and how they experiment with all their own ideas. It's really fun to do. But the Mbot, it's not enough for our needs. We also need connectivity. We need a camera, and Arduino is not very powerful, especially if you do the camera bit. Yeah, you need more processing power and memory. So I looked beyond this. What about an ESP8266? Anyone knows that? A few hands. It's a very small microcontroller and also very cheap. And it has a Wi-Fi chip and in this case antenna built in. And so it's ideal for small IoT projects that need to be cheap and but it's still not powerful enough. A small bit of memory. So I ended up using a Raspberry Pi. If you buy a Pi 3, it already has a built-in Wi-Fi, so you don't need to buy that separately. It has a standard camera interface for plugging in a camera, and it's more powerful than you need. It's good enough, and also it has a GPIO header, so it's a set of pins where you can connect other things to. So I bought this Raspberry Pi, and then we need some more things like the power. So I bought this power supply board you can plug on top of your Raspberry Pi, and a big battery, 3000 milliampere hours battery. It has enough capacity to run for hours. So we also wanted to connect sensors, so I got the Grove Pi board. This is the Grove is a standardized connection for a lot of different sensors. So you can fiddle around with wires and resistors yourself. But if you get something like this, it's quite easy to find sensors and other devices you can just plug into this Grove board. So it's very easy to get started with some IoT. And the Pi camera, it's the default camera to use on a Pi. It's easy to connect and it's small. So I thought it was cool if the camera would be able to look around separately from the robot. So I got this camera mount. It can do panning and tilting, so looking in all directions, and it comes with a servo controller board to connect it to the Pi. And well, if we put all these things together on top of each other, luckily they can just fit. If you put them in the right order, they can just fit onto each other's headers, and it looks like this. And they communicate with them over the pins. But we still have the Mbot, the base robot to be able to drive around. So you put the Raspberry Pi on the Mbot. You can power the Mbot over USB. So luckily the power supply was powerful enough to power both the Raspberry Pi and the Mbot and get it working. And also the communication can also be done through USB, serial communication. So, but this Raspberry Pi doesn't fit on the Mbot. They have different size, and they're not holes in the right place to get this working. But luckily, you can get some Lego and fix it, because the people from Mbot, they designed the components like exactly the same spacing between the holes like Lego Technics, so it can fit easily if you get the right plugs. So they also make these plugs that fit into your Mbot or other M-block things and into your Lego Technics parts. So I got these and a box of Lego Technic from my son, and I was able to build construction that I call the MarsBot. It's the Mbot with the construction with the Raspberry Pi on top. So we have the hardware, but now we need also some software to get it moving around. So again, I'm not using Java today. I used Python because most of these components you buy come with Python libraries. So you might be able to get it working on Java. Several things are easy to build in Java, but for everything there's a Python library, so it's easier to make one big Python program to get this working. So I'll show some code examples. If you want to control the camera, we import the library. You create a camera object, and you need to for some reason the way the camera is mounted into the mount, it's upside down, so you need to do a flip to get it right. And I set a conservative resolution, so it's not using that much bandwidth. Then you only need to say camera.capture and a file name, and the Raspberry Pi stores the image on its memory. And if you want to move the camera around, there's a Python library, import PyPan, create an object, and these commandos set it into a neutral position so it looks straightforward. It's good to start with. And then you can use values, do pan, do tilt, and a certain value to move it left, right, up, and down. You need to figure out what the correct positions is. If you set it beyond a certain value, it might get stuck with the cable, so you won't be able to look backwards. So you need to limit the ranges you want to set. So between 100 and 200 worked okay. Temperature data. So I got a temperature sensor to plug into the Grove board, and there's a Grove library for the temperature sensors, and it's connected to a certain port, and you can read the value from the port. But this is not the code I used in the robot, because it would continuously be reading the value. In my case, I'm only capturing the value once a minute and sending it to the server. So you can get temperature and humidity with this sensor, but there's not much humidity on Mars, so I skipped that one. And also I got a compass sensor, but I found out Mars has a very strange magnetic field. It does have a magnetic field like Earth, but unlike Earth, it's only in the southern part, and it's very erratic. It switches between positive and negative all the time. So you wouldn't be able to navigate on the magnetic field on Mars. Okay, so we have the Raspberry Pi with all the pieces working. Now I want to move around using the Mbot. The Mbot, you can send commands over the serial cable, over the USB cable, and I needed to figure out what commands would work for the Mbot. But luckily, in the Scratch program, you can enable a binary mode, they say, or a screen where you can see all the values that are sent over the serial connection if you just play around with the device connected. So this way I was able to record the values for starting a motor and stopping a motor. And in this example, you can see setting a motor to a certain speed and then and setting it to 0. So if you can do these, you can, if you use the right libraries, we can do a serial connection to the Mbot and send these values. So I defined some constants based on the hex values, and just write these values to the serial device, to the serial connection. So in this example, you start both motors, so it starts moving, and after a second you stop both motors. and then you have moved. So this worked, and you can also, of course, move left or right. So we have a robot and software on the robot, but we need more. A mission control center. So that's where Amazon comes in. You probably are already familiar with Amazon, but for people that don't, it's a big cloud service provider. All kinds of services. This picture is not even complete because they just keep adding new things. They have IoT platform for messaging between your IoT device and their services. So, in my case, I'm building a mission control center to connect to my robot over the Amazon IoT platform. Messaging you can do with MQTT. It's a lightweight messaging framework, and you can do a secure communication, of course, because you don't want, depending on your use case, you really don't want information from your IoT device shared with the rest of the world. So it comes included in the platform. You have a rules engine that you can use for interesting routing and transforming. I'll show an example later. And also an interesting feature is a device shadow. It's for devices that aren't continuously online but only periodically. Then you could have the device write some information to the device shadow, and it will stay there even if the device is offline, so you can read the last written value from your device even if your device isn't connected. You can also use it the other way around, store some information for the device, so when the device comes online it can get that information and do something with it. So Amazon's IoT platform comes with several ways to connect. We have the AWS IoT API, where you can create your applications that communicate with the device gateway. And on the other hand, we have the device SDK. That's more for the smaller, lower powered devices, the dedicated IoT device. In the case of the Raspberry Pi, you can use the normal API. And well, you have the gateway. That's the MQTT part. You can it does MQTT over WebSockets and over HTTP. And you can communicate via MQTT, either MQTT by the API or MQTT using WebSockets, and you can also communicate with it over HTTP. So, in case of the MarsBot, how would this work? So, our MarsBot would be sending sensor data to AWS IoT, and it would also needs to get instructions from AWS IoT to be able to move around. So the standard library from AWS does only allow to publish data and isn't able to subscribe on data. So in this case, I wouldn't be able to fetch these instructions. So I used a different MQTT library. It's called Eclipse Pehoe, and it's available for Python. And in that library can do both receiving and sending messages. So you need to import the correct library, some code example, and put in some information, which host you need to connect to. In this case, it's my IoT framework URL. Then you create a client, and we can add two functions, an onConnect function and an onMessage function, and just keep on running. So when it connects, it does something, and every time a message comes in, it does something. on Connect we want to subscribe to certain topics, and on Message you can send information. This is an piece of the code I used. I'm publishing information to the MarsBot/Mbot topic for motor commands. If the command's forward, then I want to move forward. If the command is left, I want to move left. And I also have a topic for the camera. So you just say publish and it sends the data. So I have a robot sending and receiving data from Amazon IoT, and now I want my mission control center. That's a web application connecting to AWS IoT as well. So we need communication both ways, and again you can use the Eclipse Pehoe library, but in this case the JavaScript version, and this one uses WebSockets and is able to communicate with Amazon IoT Platform. I won't be showing code examples. It's very similar to the Python client. Then another point, sending pictures over the IoT framework might be able to work, but I chose not to, because if you send a large piece of data, it gets chopped into little messages. So it would appear as one message, but you would pay Amazon for sending a lot of small messages. So it's more useful to look at something else. In this case, I'm storing the picture into S3 and then making the picture available to through a public URL, and the browser sending the URL over the IoT message, and then the browser can fetch the picture. So in the case you want to take a picture, the browser sends a message to Amazon. Amazon sends a message to the robot. Robot takes a picture, stores it here, and then sends a message to the browser and tells it where to find it, and is able to fetch it. And this is an example to how you can, well, if you take a picture and you can generate a URL and make it publicly available on the internet. By default it's available for 1 hour, but you could send a different time. Okay, it's demo time. I'm using my phone and my connection to get it working, so please turn off your Wi-Fi. No, just kidding, it probably worked. Let's see if we can do something with our robot. Unfortunately, this morning my robot stopped working when I pull the cable out. So first I'll try to use it with the power attached, because I think my power connection might be failing. So we could try it later on with the power disconnected. Okay, so this is the mission control center. On the left side we have some robot controls that send messages to the robot and it starts moving, and on the right side some camera controls. So let's see if this works. Move forward. Yeah, it starts moving. I hope you can see it. And then move a bit to the right. Hello there. Oh, that's too much. And let's see if we can turn the camera a bit. Okay, say IoT. Oh, this is the center button. Oops. Try again. Say IoT. Let's hope this works. Okay, I got the message with the URL, and then I fetched the picture, and we get blinded by a lamp. Okay, so too bad. Maybe if it moves a bit closer, it won't see the lamp. Yeah, the other lamp. well, at least we can see it works. Next time I need to add a little slide to be able to tweak this, or maybe this is an opportunity to use Amazon's image processing libraries to finish the picture to to be better. Other thing we can see here, it's almost off screen, and it's also periodically sending the temperature data. So it's 22 degrees at this moment, and it can move back again. Okay, so the demo worked. Woohoo! Let's see some other examples with the Amazon platform. Like I said, there's a rules engine. It's the right part of their picture. The rules engine allows you to select messages from the IoT the messaging gateway, and filter out uninteresting messages and connect to other services. So every message would be sent to this service. So you could use CloudWatch for logging them, or you can store them in a DynamoDB database, or for example invoke a Lambda function. Well, let's get to the next example. In this case, all the temperature data you might be able you might want to store, or other sensor data from your IoT device in the database. And well, in this case, you could select all messages from a certain topic and write them to a certain DynamoDB table. And you can set up this rule, and it works. Okay, some other example, connecting to AWS Lambda. Lambda functions are pieces, Lambda is a platform where you can write a piece of code and just upload it to Amazon, and they run it. And you don't need to think about servers or JVMs, or they execute your code, and there's no reason to worry about the infrastructure. So the idea is you pay exactly for the use, and not for running servers, and you also don't need to take care of for example fixes of your operating system. You hope they do that. Microsoft and Google have similar functions, cloud functions and functions it's called. But in this case it makes sense to use the Lambdas if you're already on Amazon's platform. One note, if you do run Java on Lambda, if you spin up, if you create a lot more load, it still needs to spin up some JVMs behind the scenes, so there might be some delays initially. And you can also do Python, Node.js, and for a while now also C#. So this it would look like this. You send messages to Amazon IoT, and Amazon IoT passes it to Lambda, and the Lambda function could just do anything, call other services, or anything you write in your own code. Another example, SNS. SNS is a service for sending small messages, and you can set up several different several endpoints, like some server HTTP, or sending an SMS message, an email, or you could also invoke Lambdas, but we could do that already, so that's what we don't need. For example, just push messages to your phone, you could do with SNS. Maybe if your battery is dying, then you need to send a message, I need a new battery. Another example, not an example, I built voice control with Alexa. Alexa is a small, you have a small and a large device that you can talk to Alexa, and Alexa activates some services in Amazon. And I wrote my own skill to send instructions from Alexa to the robot. How does that work? Alexa is running the skill, They call it a skill. It's some sort of an app for the device. And the app interacts with a Lambda function you write. And the Lambda function can send messages to AWS IoT. So I'm able to send instructions the same as through the web interface. So let's see if this works. I need some power. It will take half a minute to start.
Connecting to Wi-Fi?
Yeah. Something's happening.
15 minutes.
Hello.
Alexa, good afternoon.
Good afternoon. Listening to a playlist and like what you're hearing? Find out what's playing by asking me, who is this? I'll tell you the
Okay,
name of
sorry
the
about
song,
this.
artist,
Stop.
and album.
She just keeps on talking. Okay. Sorry about that. Alexa, start MarsBot.
Welcome to the MarsBot voice control skill.
Move forward.
Okay,
Move forward.
okay.
Take picture.
Picture taken.
Oh,
What
yeah.
can I help you with?
What do you see?
Alien life forms detected.
So, you see you can interact with your robot when it's driving around on Mars.
Forms detected.
Stop. Stop.
There was a problem with the requested skills.
Okay. So sometimes she listens. Anyway, we were able to move our robot on Mars while talking to it. Okay, let's do a little recap. Robots are cool, robots are fun. That's my opinion, so I hope you're enthusiastic about it as well. Mbot is a great platform to start with if you want to build a small robot or you want to entertain your kids or to get to know technology and programming. Raspberry Pi is a quite a powerful device, and you can connect all kind of things to it. It's very good, very easy to use Raspberry Pi for IoT projects. If you want to do something like running something standalone on a battery, Raspberry Pi would take too much power. But well, for fun projects, it's perfect. And writing Python code is easy, and grabbing it from the internet is even more easy. So for every piece of bit, for every thing I need, there's a library, and usually you can also find examples for how to use it. So it wasn't that hard. On the Amazon side, Amazon's platform enables you to get started with the IoT without running your own server. That's what we saw. You use their services, and you don't need to set up your own server or rent a server. You can use these services and pay per use. If you do this, if you set up an Amazon account, I believe you get 1 year some free quotum, so it won't cost you a bit, and afterwards you might pay a few dollars a month if you don't do it professionally. If you have millions of devices, it's probably getting to cost you more, but for me it was only a few dollars. MQTT is a lightweight messaging framework, ideal for IT applications. It's also easy to use, and yeah, it works perfectly with Amazon. And using the rules engine, you can connect to other Amazon services. Okay, last. This is my blog URL, and there's also one blog post for building this robot. There's the shopping list and other links you might need. And in the Netherlands, it was easy to buy these things in shops in the Netherlands, but I assume in Spain you can find a shop that has the same parts. Any questions?
You mentioned you worked with kids, and my question is, at what age do you think it's okay to start programming in Scratch or
That's a good question.
something similar?
It depends on the kid maybe, but I also did the same Mbot class with the school class of my daughter, and these kids are aged 9, 10, 11, and they were able to mostly do the things by themselves. So I wrote a small document with some help and some examples, and to get them started, and they were able to do that themselves, and well, it worked. If you go younger, it might be harder. So I think 9 or 10 years is a good age to get started with this.
Okay, thank you.
Other questions?
Yeah.
Yeah.
You choose Amazon Web Service to connect to the Arduino, but did you search for other options or other tools to connect to the Raspberry Pi and the Arduino?
In my case, the Arduino board on the robot doesn't have any internet connection. So.
But you connect the Raspberry Pi to the Arduino, and you use the Amazon Web Service to connect to the Raspberry Pi.
Yeah,
right?
exactly. Yeah. So there might be other ways to do it the same, but
Yeah. Did you look into other options, or you?
Yeah, well, and one example was the ESP 8266, the small chip with Wi-Fi. If I'm not sure if there is an SDK for it, but at least you would be able to send HTTP messages. But in the end, I used the Raspberry Pi because I needed more power, and maybe there are other options, but this is the one I ran into and seemed to fit my needs.
But with the Amazon Web Service, I meant, do you like search for, I don't know, like Google App Engine or something that you can deploy and connect to the Raspberry Pi?
Oh, you mean other services than Amazon?
Yeah.
Sorry. Well, when I looked at this, the Amazon was the first to have this IoT platform with the MQTT messaging. Google has now a beta service available also with MQTT messaging. So there's a beta you need to sign up for, but I assume they will open up in a few months. So then they are an interesting option too.
Thanks.
More questions?
Okay, thank you very much. If you